Hello everyone. In series of learning design and analysis of algorithms. So this video is about merge sort. So the very important concept in data structures. Of course, this is also important in design and analysis of algorithms because through this we will be knowing how time complexity will varies in sorting algorithms. Now let's start. So merge sort is also one of the example for divide and conquer. So there are two videos which already made available in our channel. So this merge sort also based upon divide and conquer strategy, that the whole task will get divided into subtask. Okay. Now, so this is what merge sort process, or if the question is define merge sort, also you can write this paragraph. If somebody asks you what is merge sort, also you can write this paragraph. Now, let's see what it is. What is merge sort? Given a sequence of n number of elements, that the sequence of n elements are this: a1, a2 up to an. So the general idea is to imagine them split into two sets. The two sets are a1 to an by 2 and a of n by 2 plus 1 to a of n. So this is something like again a of 1 to a of mid. Okay. And this is what mid plus 1 to high, or the maximum index. So again we'll divided the whole set into two parts. Okay. So in binary search, the set were divided into three parts. One is middle element, the other one is A2 mid minus 1, the other one is mid plus 1 to high. And we were stopped there only because we were calculated in that split. But merge sort is not something like that. Merge sort is that algorithm which divides into two parts, and this two parts again will get divided. Again will get divided to the single element. Okay. Now let's see the tree call. This is what we used to call tree call of merge sort. Otherwise tree structure of merge sort. How these will get called? Let us suppose that we have 10 number of elements. So this 10 number of elements will get divided into two parts. How will get divided? Based upon the middle element. How middle element can calculated? Low index plus high index by 2. What is low index? 1. What is high index? 10. 1 plus 10 by 2, that is 11 by 2. So we will get what? 11 by 2 in the sense 5.5 we'll get. So I told you in the last video that we will be applying floor function. So floor function of 5.5 is 5. Now, so that means what? So in the split we were seen already, a of 1 to a of mid is one partition or one split. So now a of 1 to a of mid. What is mid value? 5. So 1 to 5 is one split, and middle plus 1. A of middle plus 1 to a of high is one more split. That is a of mid is what? Mid plus 1 is what? 6. High is what? 10. And this will be the other split. Okay. Now we were in this step. So what I told you, till you get single element in the list, you have to divide it. So still the list is having feasibility to get divided because the list capacity is 5 elements. Until it becomes one element in the set, you have to divide it. So still we have feasibility. Calculate mid value. 1 plus 5 by 2, 6 by 2, which is 3. Means what? 1 to 3 will be one set. That is what? 1 to middle will be one set. What is middle value? 3. That means 1 to 3 will be one split. Middle plus 1 to high is another split. And the next is same. For this partition also same. So 6 plus 10 by 2, that is 8. 6 to 8 is one split. Middle plus 1 means 9. 9 to 10 is another split. Again these are having 3 elements. No single element. It is not having single element. But what is our objective? Till the list becomes single element, we have to divide it. Now divide it again. Calculate middle value before you divide. You can't divide the list blindly. You have to calculate middle value. According to this middle value only, the list has to get divided. So 1 to 3. 1 to 3 means what? 1 plus 3 by 2 means 2. 2 is the middle value. So 1 to 2 is one set, 3 to 3 is the other set. Now look at this. This set is having single element. Single element. So we were stopped here. We are not proceeded, right? We were stopped here. Likewise, you need to get single element in all the sets. Now look at this. One element, only one element, only one, only one, only one. So here you have two elements. Again we split it till it becomes single element. So it is also one element, one element, one element. Now this is what we divided. This is tree call for merge sort for divide. So once you divide this, again you have to rule it, combine it, means conquer it. So let us suppose that I have here two elements, right? So the two elements are, take the example that I'll take red pen. Okay. So take the example that I have elements of 5. So I'll take the example 5 comma 2, 1, 10, 6, 4, 8, 3. How many elements? 1, 2, 3, 4, 5, 6, 7, 8. So 9 and 15. 10 elements. So the list is having 10 elements. According to this tree call, you have to divide the list into two splits. What is the first split? 1 to 5 elements have to be this split. That means 5 comma 2 comma 1 comma 10 comma 6 will be under this. And here 4 comma 8 comma 3 comma 9 comma 5. Okay. Again here 5 comma 2 comma 1. This one 10 comma 6. And again here 5 comma 2 is here. 1 is here. Now again here 5 comma 2 is here. Okay. So you found here two single elements, right? Now what I am going to do is I'll handle the solution, or I will find the solution for these two elements. And these two elements, how I can find the solution is, we will perform the relation in between these two. Whether these two elements are less than of each one or greater than. That means in merge sort, we will be arranging the list ascending order. So the starting element should be less than the second element. We will compare these two elements. We will compare these two elements. So 5 less than 2. So this side lesser element should be there. This side greater element should be there. So as you found greater here, swap is required, right? So now what I'll do? So 5, 2 will be placed here and 5 will be placed here. And this 2 comma 5 E will get combined, and that will be updated here. So that's what merge sort. Merge sort is, we'll divide first of all, we will handle individually, we'll find the solution individually and we'll combine back. So again we'll be doing the solution individually, again we'll combine back. So this is what exactly what happens in merge sort. Now let's see the algorithm. So in examination point of view, you have to take one example. You should divide the list into two halves and you have to do in such a way in each comparison. Okay. Now, so algorithm merge sort, low comma high. So if low is less than high, then we'll divide P into subproblems based upon the middle element. So we'll solve the subproblems, low to mid and mid plus 1 to high. So once after you solve individually, we'll combine the solution. How we'll combine the solution? So just now I explained you, right? So these two elements will get combined, right? So how it will combine? We'll see this combine algorithm. So algorithm merge, what will merge? Low, mid, high. So these elements will get merged. How will get merges? So we'll take H is equal to low. That means what? We do have two splits, right? So just now we were taken two splits. Let us assume that my split is 5, 1, 2, 9, 10. This is my first split. Second split is 6, 5, 4, 8, 15. This is my second split. So here these are two splits I said, right? And this is my H. Okay. And this is what my middle. and this is what my middle plus 1, and this is what my H. Okay. Now low is given to H. This is my low that is given to H. This is my mid, which this is my middle. Okay, leave it. And this is low of this set, and that is given to I. And this is J, which is middle plus 1. Okay. Now look at, while H less than or equal to mid. So what you have to calculate? Low less than or equal to mid. That means this is your low element, this is your middle element. These two elements will get the indexes, not the element, indexes. H value is what? 1. Here the H value is 1. Middle value is what? 5. So 1 less than or equal to 5. So we will get inside. J also should less than or equal to high. Then we will get inside. So if any one of the condition will fail. So ante meaning enti? So ee set lo ఒక్క ఎలిమెంట్ కంటే ఎక్కువ ఉండాలి. ఈ సెట్లో కూడా ఒక్క ఎలిమెంట్ కంటే ఎక్కువ ఉండాలి. ఈ కండిషన్ ఫెయిల్ అయిందనుకోండి, అంటే దాని అర్థం ఏంటి? జే లెస్ దాన్ ఆర్ ఈక్వల్ టు హై. సో జే అంటే ఇది కదా, జే అంటే ఏంటి? మిడ్ ప్లస్ 1 అంటే ఈ ఎలిమెంట్ ఇది హై. సో ఇవి రెండు కూడా ఈక్వల్ అయిపోయాయి. అంటే ఒక్కటే ఎలిమెంట్ ఉందనుకోండి ఈ పార్టీషియన్లో, అప్పుడు వైల్ లూప్ ఎగ్జిక్యూట్ అవ్వదు. We know it, right? What is the logical end? Both the statement have to be true. If any statement will get fail, we will not execute this body. We'll come out of the body. Out of the body is this if condition. Again we'll check if condition H greater than mid, and we'll simply store the J value. Whatsoever element is left, that will be placed into your resultant array. B of I is equal to resultant array. Okay. Even if it is fail, then we will look into this value. This is what? First partition. K equal to J means what? This middle plus 1 partition. Okay. K is equal to low means what? This partition. Okay. So this is what your algorithm. So all this is about merge sort. The next video will make on quick sort. Thank you all.